Standard 10th, Science and Technology, Part 1st, Chapter number 2, Periodic Classification of Elements. In this chapter, now we are going to study the new table, the new period, new shell. Now, here some part of the periodic table is shown, and in that part, the electronic configuration of the elements is also shown. This part will give better idea about the electronic configuration and about the arrangement of elements in the periodic table. Actually, here the normal elements only are considered. ज्याला मराठीमध्ये आपण प्रसामान्य मूलद्रव्य म्हणतो, त्या प्रसामान्य मूलद्रव्यांचाच फक्त या ठिकाणी विचार केलेला आहे. इतर संक्रामक आंतरसंक्रामक यांचा विचार केलेला नाही. अँड फॉर दिस पर्पज द फर्स्ट 3 and 4th period for some extent is considered. Now see here, in case of this hydrogen is present in in group number 1, period number 1. This period number 1 indicates the number of shells present in this atom, 1. Here also the electron shell number is 1. Here in this period, in the hydrogen element, atom of the hydrogen element, 1 electron is present in the outermost, that is only 1 electron shell, and in helium this electron shell gets completely filled up. Duplet state is completed here. After filling this first electron shell, in lithium number of electrons is now 3 here. The new shell starts to be filled up. First electron shell is completely filled, and next electron shell is started to be filled up with number of electron 1, 2, 3, 4, 5, 6, etc. Number of electrons are added in the second electron shell from left to right, and here again the next, that is the second electron shell is also completely filled. After filling this second shell, new shell starts here, that means third shell starts here with new period number, that means period number 3. That means first 2 are completely filled and third one starts to be filled up from left to right. That means here sodium will show electronic configuration 281, magnesium having 282, aluminum with 283, silicon from 284, 285, 286, 287, 288. Now again here third electron shell is completely filled. First is completely filled, second is completely filled, third is also completely filled. Then next, that is 4th period starts with 4th electron shell, which is showing the electronic configuration 2881. Next is 2882, like this. So here number of electron shells shows correlation with the number of period. Here one more thing can be found here. In the group number 1, how much electrons are present in the outermost electron shell? In case of hydrogen there is only 1 electron, in case of hydrogen there is only 1 electron shell in which 1 electron is present. In case of lithium there are 2 electron shells, and in the outermost electron shell only 1 electron is present. In sodium also, in the outermost electron shell 1 electron is present. In Ca also only 1 electron is present in the outermost shell. That means in this single group all the elements show the same number of electrons present in the outermost electron shell. Therefore here they will show similarity in chemical properties. Okay, here also we can see in group number 2, in the outermost electron shell, there are 2 electrons each in the outermost electron shell. Here in group number 13, 3 electrons are present in the outermost electron shell. That means in a group, all the elements will show the same number in the outermost electron shell, and that number decides the valency of the element. Therefore, the valencies of all the elements present in a same group will be same. Also, their chemical properties along a group will be more or less similar. Okay, now what happens in a period from left to right? We will see here. In case of this period number 2, what happens is, in case of this lithium, the electronic configuration is 2,1. In case of beryllium, 2,2. In case of boron, 2,3. In case of carbon, 2,4. In case of nitrogen, 2,5. In case of oxygen, 2,6. In case of fluorine, 2,7. In case of neon, 2,8. Now, here in the outermost electron shell, only 1 electron is there. That 1 electron acts as a free electron, which in chemical reaction is easily donated. Therefore, this element loses 1 electron and gains a single positive charge. This is nothing but the valency of this element. Here in case of beryllium, it donates 2 electrons which are present in the outermost electron shell, and it shows valency 2. But as they donate electrons and acquire positive charge, these elements are considered as electropositive. Here in case of boron also, 3 electrons are present. It donates 3 electrons and accepts 3 positive charges on it. Okay, these are all metals, exception of this boron. Carbon having electronic configuration 2,4. As there are 4 electrons, it cannot donate 4 electrons, or it cannot accept even 4 electrons. Instead, this element shows the formation of covalent bonds. Electrons are shared by this element. Therefore, 4 electrons are shared by this element. Therefore, valency is 4. In case of this nitrogen, there are 5 electrons present in the outermost electron shell. Instead of donating 5 electrons, now there are force of attraction between the nucleus, positively charged nucleus, and negatively charged electrons is more because of the increased number of protons and electrons. This element accepts or gains 3 electrons from other elements. Therefore, valency is 3. But due to the exception of these 3 electrons, this element shows negativity. Again, in case of oxygen, also here 2 electrons are accepted. In case of fluorine, fluorine accepts 1 electron and completes its octet. Therefore, here valency is 3, here valency is 2, here valency is again 1, and in this case octet state is completed. No electrons are donated or accepted here. Therefore, their valency is 0. Therefore, this group is also known as 0 group. As the case is studied, in the third period also, the elements will show the valency is changing from 1, 2, 3, 4 and again from 3 to 1, 0. Thank you.